All right, so like I said, before we get into our derivatives and really the preview of calculus that we're going to do for the next couple of weeks, we want to make sure we touch on some basic and not so basic exponent rules. So the first one that we're going to talk about today, that I know if you were in Honors Algebra 2 last year, we did this. One of our big topics in Honors Algebra 2 is exponent rules, and we do these big topic assignments probably, I don't know, once after every unit, and it has practice of different topics that we consider the important topics from Algebra 2. And one of them is exponent rules. So in my Honors Algebra 2 classes, they get lots of practice with exponents. So here's what I want to do. I want to talk just for a minute about the idea of negative exponents, because that's where we want to start today, what they represent, and how to simplify / work with a negative exponent. So a negative exponent, does anybody remember what a negative exponent represents? Like, what is it in math? How do you simplify it? What's important about it?
Like 1 over, and like, so let's say 3 to negative 3 squared would be like 1 over 3 squared.
Okay, yeah, so we could take the idea of a reciprocal. If you can remember that negative exponents are just reciprocals, that's a big idea, and that's exactly what you were saying. So, for example, if I had something like x squared, let's say x to the negative 2, that can be written as 1 over x squared. And if I had something like 1 over x to the negative 2, that could be written as x squared. So what we're saying here is that a negative exponent, if you think about this as being over 1, and think about this as being over 1, they're just reciprocals. So if we have a negative exponent and that happens to be in the numerator, we flip it and it becomes something in the denominator. And then a negative exponent in the denominator flips to become something in the numerator. So the big idea with a negative exponent is understanding that they are just reciprocals. So from the worksheet or from the assignment on Go Formative, I'm going to do a couple of those from the first section. The first section instructions just say, simplify and your answers should contain only positive exponents. So that's what we're going to do. I'm just going to start with number 1. We have 4a to the 4th, b to the negative 3rd. All I want to do with this is make sure I write this so that the exponents are all positive. That's my only goal here. When I do that, it's helpful to think of this as one big multiplication problem. So it might be helpful to rewrite this with a little more intention with our multiplication symbols. Now the reason I do that is I'm going to think of each part of that product as a fraction. So I'm going to think of this as 4 over 1 times a to the 4th over 1 times b to the negative 3rd over 1. This is really helpful when dealing with negative exponents, because then I'm not going to get confused about what part is the reciprocal. A big mistake that people will make is try to move too many things around. The only thing that should move around here is that b, because the b is the only thing that has a negative exponent. So if I rewrite this, the 4 over 1 stays as is, the a to the 4th over 1 stays as is, but the b to the negative 3, that's the part where I'm going to get the reciprocal. So it'll be b to the positive 3 in the denominator and 1 in the numerator. So I like to separate each of them independently and look at them on their own. So then what I end up with, if I simplify that entire big multiplication problem now, is 4 times a to the 4th times 1 in the numerator, which is just 4 times a to the 4th, over 1 times b cubed in the denominator, which is just b cubed. And that's it. That's the only goal for that section. Rewrite it so that your exponents are all positive. Let's see. Let's pick one more. I like 5. Let's pick number 5 next. So 5. Let me move down just a tad. All right, 5 says 2x to the negative 4th times y to the negative 2. Now, once again, I'm going to take a moment and really be intentional about my multiplication symbols. So I'm going to write that as 2 times x to the negative fourth times y to the negative 2. And then even go one step further and write each of those things as a fraction over 1. Now, once you get a little bit more adept at this, you aren't going to have to go through this process every time. But I think it's good when you're starting out. So then what does that become? Well, let's see. The 2 does not have a negative exponent. It is not 2 to the negative 3 power. It's just, if there's no exponent, 2 to the first. So it's not going to move. It stays in the numerator. So I would have 2 over 1, just stays as is. That x to the negative fourth, though, that part we need to make a reciprocal out of. So I'm going to make it 1 over x to the fourth. And then same thing with our y. I'm going to make it a reciprocal and make it 1 over y squared. And then we just simplify that fraction a little bit. So we're going to have 2 times 1 is just 2 in the numerator. And then 1 times x to the fourth times y squared in the denominator. And that's it. Everything has positive exponents, and that was our only goal. All right. So that's negative exponents. Any questions on those?
Can you keep it there?
Yep. Do you guys have, remember working through things with negative exponents in it at all? If you do, kind of give me a raise of the hand. Any recollection? I'm going to guess those of you that are raising your hand maybe were in honors last year, maybe not. No. It's definitely something that should be taught. I think you do it a little bit in Algebra 2. There's not a huge emphasis on it, but it is something that shows up in Algebra 2.
It's just kind of mentioned.
Yes. You don't do a lot of coming back to it. All right, next up. Did you get everything you needed?
Yeah.
Okay. Next up, I want to talk about fractional exponents. So fractional exponents. Anybody remember what a fractional exponent represents? So like x to the 1/2 power. What does that represent? Okay, so this is one that a lot of people have trouble with. I'm going to call it the nth root because it's going to depend on what the exponent is. So for example, if I gave you something like x to the 1/2 power, that is just the square root of x. If I give you x to the 1/3 power, that is just the cubed root of x. If I give you x to the, 1/21st power, that is just the 21st root of x. Okay, it doesn't have to be a number that we actually have worked with before. It's just the root. Now, if we put together a fractional exponent with a power, what we end up with is something that looks like this. So if we had something like x to the 3/7 power, this 7 represents your root. And I'll blow that up a little bit so we can actually see what it says. The 7 represents the root. The 3 represents the power. So it's going to be 3 as your power and 7 as your root. So if I were going to rewrite this in root format, it would look like this. We would have the 7th root of x to the 3rd power. The 7th root of x to the 3rd power. Now, a couple of things about that. Well, I guess one thing really, if you get confused about which one of these means a power and which one of them is a root, if you think of the word root, hopefully the first image that comes to mind is like tree roots. And tree roots are below ground. So I would like to think about the root is below the fraction bar. That's one way you can remember it's a root and not a power. Okay, so let's actually simplify a couple of these. Now, the instructions on your assignment just say simplify. I added a little bit. I added that I want you to write this in root format. Okay, so there's a little bit more than just simplifying. You're actually going to go one step further and rewrite them as roots. So let's just start with number 9. So 9 has 3 times m to the 5/4 power. And it doesn't have the multiplication symbol between everything, but I'm going to go ahead and write it between everything. You don't have to, but it is important to understand that this is just one big multiplication problem. All right, so I can multiply in any order. Think of 5 times 4, that's 20. But 4 times 5 is also 20. So it doesn't matter if I do 5 first or 4 first, I get the same end result. And that's what you need to keep in mind when you start working through these. So what I notice here is I have a 3 and times a 2. I'm just sort of separating what each of the different bases would be. I only have one that has an m as a base. And then I have a couple of terms that have n as a base. Again, this is sort of a way to give yourself a starting point. Like, where do I even begin with this? We'll begin by putting things that would go together. In other words, I'm going to put the 3 and the 2 together because I can multiply those two things without any issues. The m is already done. There's nothing more I can do with it because there's no more m's. There's just that one m as a base. And then the n's I'm going to write together. And so now I've got the like pieces put together. And if I multiply it in the order it was written originally, or I multiply it in the order I just wrote it, it doesn't matter. I'm going to get the same result. So I can move things around a little bit to make it easier to identify those things that go together. So the 3 times 2, I can easily multiply those two things together and get 6. The m to the 5/4, I'll come back to that in a minute. But I want to focus my attention on that n to the 3/2 times n squared. So let's move over to the side here and work through this. N to the 3/2 times n squared. When we're multiplying with like bases, what do we do with the exponents? So make it simpler. If this said n cubed times n squared, what would you do with those exponents? What would n cubed times, you would add them, right? Yes, so we're going to add these exponents together. Now, one thing we need to think about, and I'm just going to add the exponents, right? I'm just going to think about what happens when I add these exponents together. We're adding things together where one of them is a fraction, so I'm going to think of both things as fractions, and then what do you have to have when you add fractions together? Common denominator. Now, look, here's the thing. We are in May of pre-calculus. You should be able to add fractions together at this point. So I'm not going to spend a lot of time on this process today because I think this is something you're capable of doing. But if you have trouble with it, I'm not going to know. Use your calculator if you need to. Just get those exponents added together. All right, so what we end up with is 7/2. Okay, so we're going to add the exponents together. We get 7/2. That's the power on n. It's n to the 7/2 power. So that's what's going to go back into our expression where n was. So it'll be n to the 7/2 power. Now that's all good and great and fine, except I've added a little additional instruction and said I want these written in root format, meaning get rid of the fractional exponents and write it with a root symbol. So as I go through this process, the 6 is fine as is. It doesn't have any roots that need to be done to it. The m is going to be written as the 4th root of m to the 5th power, right? We take the bottom number as our root, the top number as our exponent. So the 4th, make that a little bigger, root of m to the 5th power. Now the n will be written as the square root of n to the 7th power. Now, you notice I did not put a 2 out in front of the root. That's because we assume that if there's not a number there, it is a 2. So for your square roots, you don't need to put the number in there. And I'll show you how that works on GoFormative. Okay, so that's it. We simplified, we got it down to one of each base, and then we rewrote it as a root instead of exponential, which is good practice for what you'll do next year. Okay, questions on that one? Let's do one more. Let's do 11. I think this is the one I did earlier as well. All right, so we have 2. And again, I'm putting that multiplication symbol between each thing. It's not actually written like this. At least not completely written like this on the assignment. So 2 times y times x to the 5/4 times 4 times x to the 5/3 times y to the 2/3. Lots going on. But just like I did up above, I'm going to separate this into like pieces. So my 2 and my 4 are just numbers that can be multiplied together. My y's I'm going to be able to multiply together. And then my x's I'm going to be able to multiply together. Now, personally, for me, I like to put things in alphabetical order, and that's how the answers will be inputted on your assignment. I'm trying to make sure they're in alphabetical order, so if you want it to match mine, that's one way you can sort of work towards that. All right, so I'm going to start rewriting this. Now, as you get better at this process, you won't always have to go through this step. You might just be able to go to combining those pieces that have the same base. But for our notes and for our examples, I like to do this. All right, so some easy things that we can do here are for sure 2 times 4, that's 8. That's easy to do. And then we run into some fractional exponents. So I've got to think about how I can combine 5/4 and 5/3 as a power of x. Again, I'm multiplying like bases, so I will add the exponents. So I'm going to just off to the side figure out what 5/4 plus 5/3 is. What is 5/4 plus 5/3? And then that'll be my exponent on x. So need a common denominator again. Multiply this one by 3 over 3 and this one by 4 over 4 to get a common denominator of 12. All right, so let me get, let's see, 15 over 12 plus 20 over 12 equals, what, 35 over 12? Okay. That's going to be our exponent for x. So I come back into my expression and I just say, okay, well then we have x to the 35/12 power. And then we'll go through the same process to add together the y's. So if there's no exponent written, that's like a y to the first. So if we're going to add those exponents together, I'm adding 1 plus 2/3. So then get your common denominator and add. And you might be able to do this without actually working through it like this. And that's fine if you can. I just am going to show it. So we would have 3/3 plus 2/3 is 5/3. So that gives me an exponent on y of 5/3. Now this is simplified because we've been able to get it down to one of each base. Now I just need to rewrite these as roots. So anything that has a fractional exponent will be rewritten as a root. So I'll have 8. And then we're going to have x. So the root for this is 12. And the power is 35. Doesn't have to be pretty. Okay? We're just rewriting it. And then we have our y will have a root of 3 and an exponent of 5, or a power of 5. And that's how I want you to enter your answers for that middle section of problems today. Yeah. Any questions on fractional exponents? Okay, so we got one problem left to do together. This is going to be the fun one of the day. Let's do, what did I do with them earlier? I did number 20. So let's talk about number 20. Now, if you have not looked at this yet, wait till you see this problem. I hate the letter Q because I have a hard time writing it. I don't know why. It just never looks right to me. Because if I just do that, that looks like a 9 to me. Yeah. And then I confuse myself. So I always have to do the little cursive Q. Okay, so that's 20. So we have some goals here. The first is let's make sure there are no negative exponents. The second is we would like one of each base. In other words, 1Q, 1M, 1P, okay? And that's really it. I am not going to ask you to rewrite these in root format. And the instructions talk about having no fractional exponents in the denominator. If you look at the actual document, I'm not going to ask you to do that either. So make sure you pay attention to my instructions because those are the ones that you have to actually execute. All right. So there's a lot we could do here. And if you had me last year, you had Mr. Calloway last year for Honors Algebra 2, you know that we gave you problems like this all the time on your big topic assignments. So, you know, for me personally, I don't like seeing the parentheses. So that's where I would begin. All right, so I'm going to start by trying to eliminate those parentheses. You've got to understand how that works with exponents. So if we have a power being raised to another power, so for example, just to give you a simpler one, if I had like a squared raised to the third power, what is that? We don't add the exponents because a to the sixth, right? We're going to multiply the exponents together. So that's what I want to do first. I'm going to take that exponent that's being applied to everything inside that parentheses, and I'm going to multiply that 1/4 times each of these things. And then I'm also going to do the same thing down here. Remember, if there's no exponent on Q, that's just like an exponent of 1. And I apologize, it got a little messy down there in the denominator. So that's my first step. And then we'll go from there. Okay, we'll try to clean it up a little bit more. So when I go to multiply in the numerator, m to the 0, so 0 times negative 1/4 is just still 0. So we still have m to the 0. I will come back to that. Some of you are probably already thinking, well, that's just 1, and you would be correct, but we'll simplify it here a little bit more before we take care of that. All right, then we do 5/3 times negative 1/4. That'll be our exponent on P. So that's going to be negative 5/12. Right? Just multiply the numerators, multiply the denominators. And then we'll have Q raised to the negative 7/16. And then we still have the M. I'll put the first power there just to make it a little more obvious. And then P to the 5/3. And I'm going to do the same thing in the denominator. So I'll take that 2 and raise everything inside there to the second power. So that would give me Q squared times M to the 4th. So I wanted to get rid of the parentheses. For me, it makes it a little bit easier to sort of see what we have. Now I'm going to look at the numerator independently and the denominator independently. I want to just take a minute and simplify each of those things by themselves. So in the numerator, I have m to the 0 times m to the 1st. I have p to the negative 5/12 times p to the 5/3. And then I have this lonely little q. So let's talk about how to address that. Okay, so we've got m to the 0 times m to the 1st. That we can take care of. That's just m to the 1st power. We add the exponents together. We get m to the 1st power.
It wouldn't be m squared.
No, because when we take the 0 plus the 1, because we're adding the exponents together, right?
Yeah.
So that's just going to be m to the 1st power. Here's the thing that you need to know about anything to the 1st power. It's just 1. So we're really saying do 1 times m to the 1st.
Oh, you wouldn't multiply those two m's together.
Right. I mean, we are, right, but when we do that, we just add our exponents together. So whatever the exponents are, that's what your power will be. Yeah. Okay, then we have to do something with those p's. So I have a negative 5/12 power and I have a 5/3 power that I know I'm going to need to add together. So again, I'm going to go off to the side here. And you might be able to do this without going off to the side. I don't know. But I'm going to add negative 5/12 to 5/3. And then that will be my exponent on P. So common denominator. And again, I'm not spending a lot of time on explanations for this. Just doing it. because I think you should be able to do this, hopefully by now. So what does that end up being? 15/12? I believe. So I would probably simplify that a little bit. 15/12 can reduce. Both can be divided by 3. So let's make that 5/4. That's going to be my exponent on P. So if I go back to my expression, I will have P to the 5/4 power. Now, I've got that negative Q, so I've got to think about what we'll do with that. That negative Q, just that piece alone, would need to have the reciprocal action applied. So you can do this without rewriting everything out. If you just imagine what will actually happen if you apply the idea of a reciprocal just to that term, is that it's going to move to the denominator. So this term and this term alone will move to the denominator. So, because it's a negative exponent. So that reciprocal piece of the puzzle we're going to apply to just that term. So I would have then Q to the 7/16 power, because it's going to be positive once we apply the reciprocal action, times Q to the 2nd times M to the 4th. So we're pretty close here. I guess I should put M in pink since we're doing that for M. Okay. So I've got to find a way to put the Q's as one term or as one base. I've got to add those two exponents together. So once again, I'm thinking about how can I simplify this? Well, I've got to simplify the powers on Q. So I've got to take 7/16 and add 2. So 7/16 and add 2. My common denominator will be 16 this time. I think I may have the wrong answer for first period, or given them the wrong answer for first period. I'll have to address that tomorrow. So that's going to be what, 39/16? Just check my work, make sure I didn't make any mistakes. So I can begin to rewrite this. Go ahead.
Sorry.
No, you go ahead.
If you have m to the 4th and m to the 1st, you can take that out and make it m to the 3rd and then...
Yes, and we're going to do that right now.
Okay.
Yes. Okay, so I'm going to leave out the m in the numerator for just a second. We're going to come back to that, and I'm glad you asked that question because that was our next step. So here's what we know so far. Okay, we know we have p to the 5/4 and q to the 39/16. But I've got two different m's in my expression still. Here's how I approach it. I think about that smaller power of m, okay? So the smaller power of m, and I don't imagine, but actually do, moving that and performing that reciprocal action. Meaning I want to put that smaller power of m with that other power of m.
Wait, why need to do that?
Why?
Why
'Cause
can't they just be on like opposite sides?
we want one of each base. That's the ultimate goal. To fully simplify this, we want to have one of each base. And right now I still have two m's.
Okay.
Yeah. So what I'm going to do is take that m to the 1st power and perform the reciprocal action. Okay, we talked about that just means that if it's negative, it becomes positive. If it's positive, it'll become negative. So if I move that m to the denominator, performing the reciprocal action, it's going to make that power of m negative. And then I can just add my m's powers together. Now, there are other ways you could do that. You can subtract the exponents. That is also an acceptable approach. You just have to make sure that your result is going into the part of the fraction where the higher power of m was. I mentioned earlier I like to try to write my exponents in alphabetical order. So you'll notice in the denominator I have the m first and then the q. If you write it as q first and then m, I don't care. It's fine. I'll go through and I'll mark them correct. But if you want that initial green on Go Formative, I'll try to have them written in alphabetical order. Now, I did not say we needed to change these to root format, and I don't want you to actually. I want you to leave them as is. That's it. So get them. These ones are a little bit more time consuming and will take you a little more thought and careful, approaches. But the ultimate goal is we have no negative exponents and we have one of each base. And if we can achieve that, then we've got it simplified.